Hello and welcome. In this video I'll be working through the Unit 9 and 10 test review, which covers concepts including the solving systems of equations of 2 and 3 variables, being able to analyze and graph circles and ellipses, as well as solving nonlinear systems of equations and inequalities. So let's go ahead and dive on in. So both question 1 and 2 are systems of 2 linear equations with 2 variables. So I'll go ahead and show one of each strategy, but for each of them you have the decision at the very beginning to approach it either as an elimination strategy or a substitution strategy. It does not matter really which way you go, we just need to commit to one and go. So I think for this one I'll go ahead and show the substitution approach. However, the elimination approach also should work. Now, how substitution will work is we want to try and get one of the equations to have a variable isolated. Looks like in this case the y and the second one is the easier one to isolate, so I'm going to go ahead and add the y over and then simultaneously subtract the 11 the other direction, so I now have our y equals equation to be 5x and then a minus 11 if I were to move those two things. So now that I know what y is equivalent to, I should be able to then substitute it in place of the y that I have in the first equation and write down that result. So I've got 2x plus 3 times, and then best practice if I am doing a substitution is to utilize parentheses, and then it still will equal the 18, but by using those parentheses that will remind us that we do need to distribute potentially something through, in this case the 3, and then after that we'll probably do a combine like terms step as well as a move constants away type process. So from here it looks like I could combine the 2x and the 15x to make 17x, and then add 33 to move it the other direction, and get that that would turn into a 51. So then the last step to at least solve for the x here would be divide both sides by 17, and I get that x will come back equivalent to 3. Our goal now is to try and figure out what the y coordinate now would be. So I'm going to go back to substituting in place of the x in our y equals equation. In other words, just kind of go right here. And I know that y is going to be equivalent to 5 times that x value 3 that we just solved for, minus 11, which would be 15 take away 11, for a final answer of 4. So with this one, to box up our final answer for this, since it is an ordered pair, I'm going to go ahead and just make sure that I write it in that correct format. So this should come back 3, 4. Alright, second example, as you can see, same general setup. I've got 2 equations and 2 variables, so our options still are the substitution or elimination strategies. This one, if I were to choose substitution, I think we can kind of see that substitution would involve having some fractions, whether I isolate an x or a y, no matter what. So elimination, I think, would be the easier route through the problem, but technically both would work in the end. Now, I did intentionally put this one on the test because the ordered pair in the end is actually a little bit uglier numbers, and that's more with the intent of if we can handle when numbers are a little bit uglier, hopefully that makes it to where we're okay if the numbers actually work out nicer. So again, the end answer for this one, foreshadowing, is a little less friendly compared to the answer before. Now, as far as how do I get the ball rolling with this one, if we're going to do an elimination approach, we have to make a decision on whether we want to eliminate the x's or eliminate the y's. I think it's a little easier to make the 4 and 3 on the x's match compared to the 3 and the 11 on the y's, but technically either would work. I'm just going to go with the one that's a little bit smaller numbers. So if I want to make the 4 and the 3 match, they can both turn into a 12, so that would mean the top equation I'd have to multiply by 3, and the bottom equation I'd have to multiply by 4. So I'm going to go ahead and just do those two things and rewrite the new results down, so I'm scaling up. In other words, here it would be 12x plus 9y equaling 9. The second one would be a 12x plus 44y equaling 52. So now what we'll do vertically is just make a decision as to whether adding or subtracting is going to eliminate the variable I'm going after. So since they're both positive 12x, subtraction is that operation I need to use. 12x take away 12x, that's going to zero out like I expected. 9y take away 44y would be a negative 35y. And then 9 take away 52, that would give me a negative 43. So then the next step, or what I would need to do next, is essentially just divide that negative 35 over. And as you can see, my foreshadowing of this not being a super nice, perfect number, it's a little bit uglier than maybe we expected. It's still fine. It's okay if we end up getting those numbers. It's just going to make the back substitution next a little bit trickier to kind of deal with, but we can hopefully still handle it. So now I'm going to make a decision as to which equation I want to plug back into. I think I'll just go with the top one to allow us to solve for the x. So I've got 4x plus 3 times that fraction I just found, 43 over 35, and still equal to 3. And so now I just need to figure out how I can start simplifying things. So multiplying that fraction with the 3, I can go ahead and just do 3 times 43 on top, and that takes me up to 129 over 35. From here I would need to subtract that 129 over 35 over. And since we have a fraction involved, we need to think common denominator. So I'd have to do 3 times the 35, which takes me up to 105. So this is really 105 minus 129 over 35, and then still equals the 4x on the left. So now simplifying that, 105 take away the 129 takes me down to a negative 24 over that 35. And then the last step would be divide by 4, which really is the same as multiplying by 1/4. So I can now say, or see, hopefully, that the x would now equal, if I did 24 divided by 4, that would be a 6, so this would be a negative 6 over a 35. So final answer for this one, if I go ahead and just box it up here in the bottom right, I've got my x-coordinate I just found to be negative 6 over 35, and I have my y-coordinate that I found first to be 43 over 35. All right, moving on to number 3. Notice now we have a system of 3 equations and 3 variables. So our same options still apply. We have substitution or elimination as our possible approaches. I think I'll do this one with a substitution approach just because I think that's a little bit more where most of you would probably prefer. So I'm going to pick, I think, those bottom equations since all of those have coefficients of 1. And I think I'll just get x by itself. So we'll go ahead and leave x there, which means I'll need to subtract y to move it over and add z to move it over. And I get my new equation is x is equivalent to a negative y, a positive z, and a negative 3. And z was a little subpar. So at that point now I should be able to take that expression and replace the x's in the other 2 equations. So it's basically going to go now into those 2. I don't want to back substitute into the bottom one because essentially everything would just zero itself out because it's the same thing. So if we go ahead and do that substitution now into those 2 equations and just rewrite and simplify what those would turn into, I've got 4x plus, 4 times that x that I just found, negative y plus z minus 3, plus the y minus the 3z equaling 11. I'll go ahead and simplify a little bit of that by distributing the 4 through. I've got negative 4y plus 4z, take away 12, plus y minus 3z equaling 11. And then combine some like terms and probably also move the 12 over. And I get, let's see, negative 4y and positive y, that would be negative 3y. 4z take away 3z, that's just positive 1z equaling 11 plus 12, that's going to give me 23. So then I'll do the same general thing, but this time with the second equation. So if I do that off to the side here, I'll kind of separate this a little bit. I've got 2 times that x value, so negative y plus z minus 3. Take away the 3y, add the 2z, equal to 9. Now distribute the 2 through. I get negative 2y plus 2z, take away 6 minus 3y plus 2z equaling 9 still. Looks like I can add the 6 over with the 9, that way it's out of the way, and combine my like terms. So negative 2y and negative 3y make negative 5y, 2z and 2z make 4z equals, and then 9 and 6 would make 15. So now essentially I'm going to go ahead and bring those things back together and write this as a new two variable system. So this would be negative 3y plus z equaling 23 over a negative 5y plus 4z equaling 15. So similar to what we just did on the previous two problems, here I have the decision of, do I want to continue in the substitution idea or do I want to eliminate? I think I'm going to go ahead and just, because it's not too tough to make the z's match, I think I'm just going to multiply that one by 4 and rewrite it underneath here, and then find a way to eliminate the z's. So that gives me negative 12y, positive 4z equaling, let's see, 80, 92. And it looks like to cancel z I would need to subtract, so this is actually going to be negative 5 take away a negative 12, so that's going to be like negative 5 plus 12, which is 7y. 4z minus 4z does 0 out, and then I've got 15 take away 92, and I get that that would be negative 77. So then the last step here, as I think we can foreshadow, we're going to divide by the 7 and get that y should equal negative 11. So now that I have the y, I can go back to either of the two equations to get the z. I think the one on the left is a little bit easier to deal with, so this is kind of getting a little crazy with where I'm going, but if we've got that one here, I can go ahead and then substitute that into this expression, get negative 3 times negative 11 plus z should equal 23. So since that's 33, if I subtract 33 from both sides, that will give me my z, in this case of negative 10. Then the last step would be pick what I had at the very beginning. I'm going to go ahead and just take those two things and substitute it into my x equals in the top right of the screen right now. And if I go all the way up there, it's going to be x will equal my negative y, so negative 11, we'll switch that to positive 11, plus z, so that's going to be plus negative 10, and then minus 3. So I've got 11 take away 10 would be 1, take away 3, that would be negative 2. So then final answer for this one, to box up or circle, would be, I'll do it in the bottom right here, I've got my x value was negative 2, my y value was negative 11, and my z value was negative 10. And for all three of these questions, I know I didn't do so. You can always go back and double check by plugging into all of the equations. If it truly is a good solution, it should make true statements for all of them. Alright, moving on to number 4. This one we now have to actually set up a system, so a little bit more complex than the last three. But it does look like I only have two variables to worry about with quarters and dimes. So here we can go ahead and set up or define whatever variables we want to use. I think I'll stick with x's and y's, but you could use whatever variables you want. I'm going to go with the quarters being the x's and the dimes being the y's. So for this one, we know we have 48 total coins, so I need a sum statement with the x's and y's that would create that. So that should just be the sum of those two things. X plus y should add up to 48 total coins. And then the values of each, I should be able to kind of multiply by each of those to see what adds up to the total amount that they gave us, $8.70. So let's go with 0.25, so quarters first, plus, and then dimes, that's just 0.1 or 0.10 if you wanted to, y equals 8.70 or 8.7. So for this, I think getting the decimals out of the way as soon as possible might be beneficial, or I could also just try and get the y's to match right now. If I just multiplied by 10, technically that would get me to have the y's match, so I think I'm going to go ahead and just do that strategy. So if we multiply that bottom one by 10 and rewrite, I've got that will now be 2.5x plus y equaling now 87. So now I can go ahead and rewrite maybe the top one underneath this. This is going to be x plus y equaling 48. And go ahead and subtract. It looks like vertically will be what I need to do. So if I go ahead and do that subtraction, this will now turn into 2.5 take away 1 would be 1.5. X equaling, and then 87 take away 48, that's going to give me 39. And then the last step will now just be divide that 1.5 over, and 39 divided by 1.5 gives us an x of 26. So I know for our answer over here in the bottom right, I know that the number of quarters is now going to be 26. And we can go back up to where it had the x plus y equaling 48, more than likely would be the easier to use, and just say, well, 26 plus y should equal 48. So really I just need to take away 26 from 48, and we get that there would be 22 left there. So I know my dimes, or the total number of dimes, would be 22. All right, number 5 now. So we're transitioning into the circles and ellipses analysis and graphing. So here it just wants us to identify our center and our radius and then make our graph. So this one hopefully will be one of the easier ones on the test in theory. We'll go ahead and just identify each of those key parts. Keep in mind an equation of a circle in its general form should be x minus h as a quantity squared, added with y minus k as a quantity squared, equaling our radius being squared. So our h and our k, we just need to look at each parenthesis that it's supposed to correspond with. So h is going to come from this x parenthesis. If I think in terms of what's in that same spot, it looks like it would be a 5. The other way you can look at it is what would make that parenthesis equal 0, which also confirms it would be 5. So I know my h value is 5. Similarly, I do the same thing now, but with the y parenthesis, what's our k? Since the subtraction is switched to addition, it must be negative, or as I just did with the other parenthesis, we could also think what makes that equal 0, which would be negative 2, and we get our k value. So I've got 5 comma negative 2, which I can go ahead and plot actually on our grid as well. So going over to 5 down to negative 2, there we go. Our radius, on the other hand, is going to be whatever this last number is. So technically it's r squared would equal then that 9. So to solve for r, each time I would just take the square root of that number, which in this problem actually is a nice perfect square, 3. So now that I know that the radius is 3 and I have my center plotted, essentially I now just go out each direction that I can on this grid. So up, down, left, and right would be the ways I would go at a distance of 3. So I'm going to count right 3 from my center, up 3, left 3, and down 3. And then from here we just do our best to try and draw a nice circle that goes through those points. Okay, number 6, now we got more of an ellipse analysis. So this one is, if we think in terms of what is the format, normally an ellipse would be an x minus h squared plus a y minus k quantity squared, and it's going to be either over a squared or over b squared. Based on what I kind of see over here, we know the larger of those two numbers should be the a squared. So this one looks like the a squared would be under the y, the b squared is going to be underneath the x, and then it's always equivalent to 1. So this one, because of the larger number being underneath the y, we know that that means it has a vertical major axis, or we can also just say I know it's going to be longer vertically. So to get to my vertices, or sorry, the major vertices as well as the foci, I know I'm going to go up and down. So I'm just going to remind myself it's up and down for each of those, which then means my minor vertices are going to be left and right. Now the amounts that I'm going to go, major vertices is always going to be the A, foci is going to be the C, and then the minor vertices is going to be B. So now my goal is to just figure out what are those numbers, as well as what is the center as we move forward. So I'm going to go ahead and just identify the center to start. Similar to a circle, it's just set each parenthesis equal to 0. So h is going to come from the x parentheses, so that's giving us a center of negative 3. and then our k would come from the y parenthesis, which looks like would be positive 1. From there, I just need to identify what the other values are, a, b, and c. I'll go ahead and just identify the squared versions first, since that's what they are to start. So a squared is the larger of the two denominators, that's the 16. B squared then must be the other denominator, 9, and then c squared is just those two subtracted as it was included here. So 16 take away 9, that would be a 7. So then to identify each of the individual amounts, in this scenario, the a, b, and c, it would just be the square root of each of those numbers. So a in this case will be 4, b will be 3, and unfortunately c, with it being a non-perfect square, it's just going to stay a square root of 7. So now we have to go with either plotting points on the grid and counting, or we can just figure out what the ordered pairs are over on the left. I think I'll just go ahead and do the 2 points on our grid, and then we'll worry about, over on the left here, and then we'll worry about putting it on the grid afterwards. But it doesn't really matter the order in which you do these. In fact, we can kind of do both at the same time if we really wanted to. So I'll go ahead and get the point of the center plotted, and then from there I know I'm going to go up and down the A amount, because again it has that vertical major axis. So 4 higher than our 1, I know my x-coordinate -3 is going to stay the same, but up 4 higher, that would be at 5, and then down 4, that's going to take me down to -3. But again, we could also just count on the grid, 1, 2, 3, 4 up, did in fact end up at 5 for a y-coordinate, and then 1, 2, 3 down, 4 down, took me down to -3 on the second point. Now my minor vertices are going to go left and right, now 3, so that's actually going to change my x-coordinates. So 3 higher than -3 would be 0, so 0, 1 is one of the ordered pairs. 3 less than -3 would be -6. Again, keeping the y-coordinate, but we could also count 1, 2, 3 to the right, see that yes, in fact, 0, 1 is one of the points, and then 1, 2, 3 to the left did in fact turn into -6 for the x-coordinate. So right now, I actually have enough to be able to draw my graph, so I may as well just knock that out, where I just try and make it as nice and smooth through those points as possible. And then the last thing I really have to do is the foci, which I don't really have to add onto the graph. In fact, I don't need you to. Here it's just going to be, let's figure out what those would be. Again, they are on the major axis, so they're going to go up and down from our center. So the x-coordinate -3 does not change. And if I go up and down, ultimately all I'm going to do is add and subtract. So here it's going to be 1 plus rad 7, which doesn't combine very well. And then the other one would be 1 take away rad 7. And we'll just leave it in that format. All right, number 7 now. We've got a system of nonlinear equations. So this one's just a 2-variable system, so that's at least kind of nice. In some cases, it might be beneficial to just at least think of what would this look like. So the top one looks like it would be a linear equation. We could manipulate that if we wanted to and get y by itself just by interchanging the 7 and the y. So we could have this in a y equals format. By adding y to the right but then subtracting 7 the other way, I get 2x take away 7. So visually that looks like it would be something that has a lower y coordinate with a slope of 2, so I'm going to guess it would look something kind of like that on this rough sketch here. The second one looks like I've got a parabola that would potentially open up and we'll cross the y-axis up at 5, but maybe has a couple of x-intercepts that we could figure out. So I could go with what's the factored version of that. So let's maybe just do that underneath here. Factored version of x squared minus 6x plus 5 would be an x minus a 5 and an x minus a 1. So it would be crossing at positive 1 and more than likely positive 5. So something that goes probably kind of like that. So I'm expecting this to have 2 solutions when it's all said and done, as you can kind of see from that picture. Now, as far as our approach is concerned, I would say this is more of a let's do a substitution idea, since I do have a y equals already in both cases actually, so I could actually just set them equal to each other, or I could look at it and go, well, since this is what y equals in one equation, let's just put that in place of the y in the other and rewrite what that would be. So off to the side I could say, well, this is now x squared take away 6x plus 5 being equal to the 2x minus 7 that I was able to get from the top one. We also could have technically just plugged into the y before I moved it over, but since I already had it isolated, that actually was kind of nicer to deal with. Anywho, from here I would want to recognize that this is definitely a quadratic format. So getting 0 on one side is a good next step. So subtracting 2x over and adding 7 over gives me a new quadratic x squared, take away 8x plus 12 being set equal to 0, and then the hope is that this will factor nicely, which what multiplies to 12 that adds to a -8, that does actually have a pair that works. -6 and -2 would make those two things happen, so I get my two x coordinates must be a +6 or a +2. So now to get our y's that they would pair with, we actually need to be a little bit specific about which ones go with which. So I'm going to specifically say when I plug in an x value of 6, let's see what we get with our y. So when I plug into our y equals 2 times x take away 7, this will be 2 times 6 take away 7, so 12 minus 7, which gives us an answer of 5. Sorry, I got a little ahead of myself there. So I know one of my ordered pairs, if I go ahead and maybe write that, let's see, where's a good place for that final answer here? Let's just go top right. I know one of my ordered pairs is going to be 6, 5. The other one will do pretty much the same general approach. We're just going to separate it here a little bit. This is now going to be when I plug in specifically an x value of 2, my y is going to equal 2 times that x value 2, take away 7. So that's a 4 take away 7, which would then give me -3. So my other solution, up in the top right here as well, will be our x was 2, and our y we found specifically for that value was a -3. And voila, we've got our 2 points of intersection, which we could go back and look at our rough sketch. The fact that they're both positive x values seem reasonable for our rough sketch, as well as having one that's got a positive y, another that has a negative y. So at least the logic of those 2 points would make sense, but again, we can also double check by plugging back into both original equations and making sure that it gives us true statements. Okay, number 8 now, notice same general thing. We've got we have a system of nonlinear equations. We've got 2 equations, 2 variables, but one of them is nonlinear. The top one there looks like it would be a circle. So if we just maybe, again, kind of start by what would this look like and how many answers might I get? That's not necessarily the worst idea in the world. Here, if I go ahead and sketch a picture of what we've got a circle centered at, it looks like 2, 1. So maybe just off to the side here, point out some of the facts that we have. We have a center, 2, 1, and then we have a radius, in this case of square root of 9, which would be 3. So I can go over 1, 2, up 1, and then count out 3, 1, 2, 3, 1, 2, 3. So 1, 2, 3 to the right, 1, 2, 3 to the left, 1, 2, 3 up, and 1, 2, 3 down. So it's going to be roughly something kind of like that. Second one looks like is just an equation of a line with x-intercepts and y-intercepts of both 6 or having 6 involved. So that's going to be 1, 2, 3, 4, 5, 6 up, 1, 2, 3, 4, 5, 6 over. So something like that. So I'm expecting there's a high likelihood I might be able to intersect with each other, but again, that's a rough sketch. Maybe that line is actually only going to touch at one spot. So with that not being perfect, those are at least my observations, but it definitely looks like it's going to be, if there are points of intersection, something in the first quadrant. So all of my x's and y's I expect to be positive. Anywho, as far as the how do I actually solve, this is now going to be a substitution or elimination approach. Seems like substitution really is the only option for this one because there's not much that pairs up for elimination to work. So I'm just going to make a decision as to which one I want to substitute in place of. I think I'm going to go ahead and get y by itself, so take away x. I get y is equal to 6 take away x. So should be able to now take that, substitute it in place of the y that we have, and start that solving process. So in doing so, I've got 6 take away x in that spot, minus 1 more, being squared equaling 9. And now start at least doing a little bit of simplifying with each of the things that we've got. So it looks like I'm going to have to expand out some powers regardless of what I do. Here I can maybe rewrite this as, that's 6 take away 1, so that's really a 5 minus x that's going to be squared, just to make it a little bit easier in the next step. So if I multiply out the x minus 2 squared, I get x squared, a minus 2x and a minus 2x in the middle make negative 4x. and then a negative 2 makes a positive 4 at the end. Doing a similar step with the 5 minus x. If I square that, I get 5 times 5 would be 25. A 5 and a negative x is negative 5x with another one, so negative 10x in the middle. And negative x, if I multiply by itself, would be a positive x squared. So we've got all of our terms kind of listed out. Looks like I do have at least some like terms. It does appear that this is going to be quadratic, so I'm actually going to do a set equal to 0 step here eventually. So I may as well just point out I'm going to subtract 9 at some point and then combine. So I've got x squared and x squared for a total of 2x squared. Negative 4x and negative 10x, that's negative 14x. Then I've got 4 and 25 is 29. Take away the 9 though that I'm moving over, and that gives me a 20 at the end, and now it's set equal to 0. What at least is a little bit nice about this one is solving wise I can go ahead and see, since they're all divisible by 2, I could just divide both sides by 2 and turn this into a little bit nicer quadratic of x squared minus 7x plus 10, and then the 0 divided by 2 stays 0 anyway. So now try factoring. It looks like I do have at least a pair of factors that will work. What multiplies to 10 that adds to a negative 7 would be an x with a negative 5 and a negative 2. So it looks like my two x's are potentially going to be positive 5 and positive 2. So to get my y's, recall we're going to have to go back and substitute in place of what we said y equaled. Since y is just 6 take away x, I'm going to go ahead and off to the side just kind of say when x is 5, let's see, let's just do it in the bottom left here. So at x equals 5, my y is going to equal 6 take away 5, which is 1. So one of my answers is 5, 1. The second answer is going to be, if I plug in an x of 2, y equaling 6 take away 2 would give me its y coordinate be 4. So the other point in this case is going to be 2, 4. And there's my two solutions. The fact that they came back in the first quadrant kind of is justified with our rough sketch at the very beginning as well. So it seems like it checks out. But again, like all other systems of equations, we can take those points, plug it back in. It for sure works on the bottom one, we can likely see. But the top one, maybe have to do a little bit of work, but it does happen to work out in this scenario. All right, now on to the last concept on this test, which is solving and graphing systems of inequalities. So here our point is going to be, or at least the main things we're going to need to be paying attention to is should I be drawing lines solid or dashed, as well as which side of that line will I shade. So each of these we can have different kinds of equations be presented, or at least graphs be presented. This one looks like we've got a quadratic, so a parabola, and then it looks like we have a linear equation. So ultimately I'll just have to figure out what do those things look like and identify their key features and plot them accordingly. So if we go ahead and just jump on in, I know the top one is a quadratic, so I know it's technically a quadratic that opens down. And I know it opens down because of the negative on the x squared. I just need to now figure out what is the vertex of it. So that's where I could go through and fall back to some of the things from earlier in the year, doing like negative b over 2a for our h coordinate, or we could complete the square, or we could even just find what are the x-intercepts and see what that would turn into, or just try and manipulate this in a way that would hopefully factor nicely. But I think probably just doing identify the vertex using negative b, so it'd be negative 2 over 2 times a, which would be negative 1. That gives me negative 2 over negative 2, which is positive 1. And then plug that back in. If I plug in 1, I get negative 1 plus 2 plus 1. So it looks like I get that that would equal 2. So my vertex is 1, 2. And again, we know it opens down and it has not really been stretched, so it's going to go by odd numbers. So I'm going to go ahead and just get that plotted. We know because of the or equal to as well that this is going to be a solid line. So when it comes to connecting all of the dots, I know it's just going to be one smooth continuous curve. So over 1 up 2, there's my vertex. Down 1, out 1 each direction, then down 1, 2, 3, out 1 each direction. Down 1, 2, 3, 4, 5, out 1 each direction, and there we go. We've got any and all points that we could have fit on this grid plotted, which may help with the identifying points of intersection for the end of this question, since it does have that secondary part. But again, I know it's a solid line because of the or equal to, just to reiterate that. Now the second one, we can go ahead and look at that and just identify that yes, it truly is a line. So since this is a linear equation, we could just do our x and y intercepts. So if I plug in 0 for each, this is again a line. If I plug in 0 for x, I'd have y equals -1, so I know I have a y-intercept at -1, or at least with a y-coordinate of -1. And then I know I have an x-intercept. If I plug in 0 for y, that would be -x equals -1, so that's actually going to be +1. The other option I could have done is just get y by itself. I could have turned this into a y equals mx plus b format by just adding the x over, so this would be like y equals x take away 1 as well, if you wanted to think of it that way. So now if it comes to plotting those points, I'm going to go ahead and just plot my x-intercept at, x and y-intercepts both at 1 and -1, and if I just continue going with the slope of 1, notice we already have found one of the points of intersection. In this case it would be, if I just kind of point it out off to the bottom left here, one of the points of intersection is, it looks like 2, 1. And then the other one, if I continue just plotting my points going the other direction, I've got one at, or another one at -1, -2, it looks like. Now this one, because it doesn't have the or equal to, I know is actually a dashed line, so I'm going to go ahead and just draw this as a dashed line as we go. And then we'll worry about the shading portions after the fact. But again, since we've already identified the point of intersections, let's maybe just identify it off to the side. I've got -1, -2 was the other one. So we at least have that part of the question addressed. The last thing I have left to do though is the where do I shade. So let's just go one at a time. Let's see, with the parabola, it looks like I can actually use the origin in both cases. So I'm going to use that as my test point. If I plug in 0, it would be, is 0 less than or equal to 0 plus 0 plus 1? Is 0 in fact less than 1? Yes it is, so I know I would shade under the parabola. So I'm going to go ahead and just kind of roughly, let's see, choose a different color here. I know it's just going to be sketched underneath there, or at least shaded underneath the parabola. For the line, if I plug in 0, 0, let's see if that one checks out. So this would be plugging in 0, I'd have 0 minus 0. Is that greater than -1? Is 0 greater than -1? Yes, it is. So I know I would shade above, or at least on the origin side. So that's going to be everything on this side of the line. So where would the overlap actually be? Well, the overlap would truly be this portion in the middle. So I'm going to go ahead and just kind of sketch that part in and erase the other parts. So my final answer would be our graph where it's been shaded in between. Just happened to work out because that's what made it true in each equation, above the linear part but below the parabola, and voila, we've got our answer. Notice again, the parabola was solid because of the or equal to, whereas the line was dashed because it did not have the or equal to. And we finally made it to the last question, number 10. So this one again, just graphing and solving a system of inequalities. So similar to the last one, we just need to be thinking about which side should I shade, as well as should I make the lines solid or dashed. Now with this one, both of them, as you can see, have an or equal to, so I'm going to go ahead and just remind myself or tell myself for sure I'm going to have solid lines. I don't have to worry about doing anything dashed. And what kind of things do I have? Well, it looks like this top one here is a circle. So let's just maybe state some facts that we know about that circle. We know it's hopefully got an, has a center at, looks like x plus 3, set that equal to 0. I get -3. Y take away 2, I get +2. So I got my circle's center at -3, 2, with the radius of square root of 25, which would be 5. So I'm going to go ahead and just get that plotted over on our grid. Go to the left 3, up 2, count out 5 each direction. 1, 2, 3, 4, 5. 2, 3, 4, 5. And so on and so forth. So now I know it was again a solid line. I can go ahead and try and draw a nice smooth circle through all of those. And then if we wanted to, we could double check using maybe the center point and just remind ourselves whether we're going to shade inside or outside. In this case, if I plug in, say, the -3, 2, I'd end up with 0 plus 0. Is that less than 25? Yes, it is. So I know I'm going to shade inside when it's all said and done. Again, I want the overlap. So if I just make mental note here, it's going to be technically shaded on the inside. The second one looks like we've got more of a linear equation, so I think maybe just putting this into y equals mx plus b format would make sense. Or we could also go, if this is a line, just identify what the x and y intercepts would be. So x-intercept looks like it's going to come back. If I plug in 0 for y, I'd have -x equals 2, so that would come back -2. Y-intercept is going to be at, if I plug in 0 for x, that would be 2y equals 2, so y is going to equal 1. Or, as mentioned before, we could also just move the x over, so it would be x plus 2, but then divide the 2 over as well, and break that up and say that this is really like 1/2 x plus 1. So when it comes to making that graph, let's go ahead and get it at least on the grid. X-intercept we said was -2, y-intercept we said was 1, or we could have done the slope of 1/2. And if I go ahead and keep plotting all the points in each direction, looks like we've got a couple of points where maybe I wasn't super accurate when it came to drawing my circle, but it looks like I've got one at 2, 2, and I've got another one at -6, -2, if I were maybe a little bit more precise with our circle. But we could also go back and do a substitution approach from before. I just more want you to, if you think it's close, at least double check in this scenario. So we know it's obviously on the line. It's more just a matter of does it work with the circle. So let's maybe just try plugging in 2, 2. 2, if I plug it in, I get 5 squared plus 0 squared is 25. So that point 2, 2 does check out. So I'll just start pointing those things here in the bottom left. My POI, or points of intersection. For sure one of them was 2, 2. That one checked out. And then the other one we said was maybe at -6, -2. So if I plug in -6, I get -6 plus 3 is -3. That squared would be 9. And then let's see, the other one, -2 minus 2 would be -4. Squared is 16. 9 plus 16 does equal 25. So that ordered pair also checks out. So -6, -2. I'm good with my points of intersection from there. Now this one we already had stated earlier, or at least did state earlier. It's also a solid line, so we may as well just go ahead and connect all those points that I was able to plot. And now I just need to figure out which side do I shade. So again, looks like we can use the origin for this one. If I plug in 0, 0, is 0 minus 0 greater than 2? Well, 0 is not greater than 2, so that means I'm going to shade above the line. So my final answer would be the inside of the circle, but only above the line portion, so it would be this portion of the graph. Anywho, hopefully this video has been helpful for those that wanted to watch it. But just like anything else, if you feel like there's extra practice problems you might need, come find me. We'll work through it. But I appreciate you taking the time watching it. We'll check you later.